Hi, everyone, and welcome to today's session. My name is Corey Dow, and I'm a technical marketing engineer with HPE Aruba Networking. We'll be covering a feature introduced in AOS-CX 10.15.0005 called Route Target Rewrite Across Fabrics. So we have our typical agenda layout for these training sessions. We'll cover the benefits of using the feature, how it's configured, best practices in troubleshooting, followed by a feature demonstration. I've also included the sample configurations and additional resources to help with deploying the feature into production, and let's get right to it. Okay, so again, we're calling this feature Route Target Rewrite Across Fabrics, but essentially it boils down to two new features that we've introduced, and you can see them kind of called out here. So Route Target Auto Mode Legacy is now made available with 10.15, and also the replace RTASN command that you can see listed here, and we'll describe that in a moment. So in this topology diagram, we have two fabrics here. So on the left-hand side, we see fabric 1 with ASN number 65100, and then fabric 2 on the right-hand side with ASN 65200. And they're connected, these two router IDs are connected using an eBGP tunnel as illustrated here with the blue icon. So prior to 10.15, the routes imported from the peers required manual route target imports within the EVPN VLAN configuration. And you can see an example of the manual route target imports as you see listed here. This is what will go away when we use the Auto Mode Legacy and replace RTASN features to simplify the configuration. So in route targets, when they're auto-generated, they're based on two different formats as defined by the two RFCs here, RFC 8365, which is the default, which has a 2-byte ASN prefix with a 4-byte suffix. And then there's also the RFC 4364, which is configured with the new route target auto mode legacy command, which has a 2-byte ASN with a 2-byte suffix matching the VNI. And you can see an example of what that looks like here with RFC 4364. So that's that format there. We'll see the other format in an upcoming slide. And so the neighbor replace RTASN, it's configured within the BGP context, as you see here underneath the EVPN context. And what this allows you to do is it allows this router to rewrite whatever the incoming route target is with the ASN of that specific router itself. So as an example of what it would look like, so we have this MAC here, the 00BB with 10.1.1.11, communicating across the fabrics to this destination over here, 10.1.1.10. And so when we have the replace RTASN feature configured, we see here the router ID 6.6.6.6 is actually the border itself. So when this packet comes from the other side, from the other fabric over to this VTEP1 with replace RTASN, it's going to go ahead and rewrite that. The route target would have initially been 65100, or I'm sorry, 65200:10, and it's now rewritten at 65100:10, so that the MAC entries can be programmed automatically without having to have these manual imports in place. And so replace RTASN, it works with both route target formats, both the RFC 4364 and RFC 8365, and manual route targets as well. And we'll see what this looks like later in the demonstration. Simplest approach is to just configure the route target auto mode legacy on every device in each of the fabrics, and to use replace RTASN to rewrite the ASN for the entries learned for other fabrics. And this just simplifies the route target configurations that are required. And so an alternative approach, as we can kind of see over here, is you can manually configure the route target imports and exports on the leaf nodes and use replace RTASN to rewrite the entries. So it's indicating that the route target auto mode legacy, it's not required, but it is preferred to simplify the configurations. Okay, and so in this slide, we can see the platform support for each of these two features. They're primarily targeted to data center switches, as you can see. In fact, these are all data center switches. And so we've provided support for all the platforms that you can see here, even the new 8325P platform with the release 10.15.0005. The only exception to that is the 8325H, which hasn't been released yet. And so that support will come in a future software update or firmware update for 10.15 in the upcoming year. So for use cases, the features are relevant with multi-fabric data center deployments with eBGP peering, as we can see an example here. With a single AS, the replace RT ASN feature isn't used, as there's really no need to rewrite the ASN because it stays the same as it would cross the fabric. And it supports stretched L2 VNI between fabrics and no support for L3 VNI. And so customer benefits we've kind of already talked about. So better usability, as prior to 10.15, we required the manual route target imports to import routes under the EVPN VLAN context for every VLAN that you have configured in the system. And this also provides better interoperability in mixed vendor data center environments. So just some additional details about the features. So the feature is used to support auto route target assignment or creation for eBGP peers. So by default, we've already mentioned this, route targets are auto-generated based on the RFC 8365 format. And the configuration commands introduced, as we already mentioned, so route target auto mode legacy. Again, this command is not required, but does simplify the configuration for the auto RT. And neighbor replace RT ASN. It's configured again underneath the BGP EVPN address family configuration. As we already talked about, enables rewriting of the ASN portion. It's also supported under the peer group configuration as well, and it overrides extended community if applied via route map in the inbound direction. So if you're using a route map to set the ASN number, then this command will override whatever that configuration is that is in place. Okay, as to caveats, there really aren't many. So just you want to avoid the mixed bag of configurations where you have manual and auto route target assignments, as that's not supported. You want to maintain consistency across the fabrics in terms of how the route targets are created. If you want to use manual, then that's fine, but don't mix the two. And the only other thing to keep in mind as well is that, so with the particular topology we showed earlier, so you may have thought that the border would be responsible for just setting the replace RT ASN and then transporting that across to the other iBGP peers straight from the border. But just keep in mind that the replace RT ASN feature is local to the router. So even if it's set on the border, it still needs to be set on the iBGP peers as well. Okay, so let's take a look at these two features when they're configured together or apart from each other. So in figure 1 here, we can see the configuration for leaf 1. So this is the VTEP 1 here in the earlier topology that we looked at. And so we've configured the auto mode legacy command under the EVPN context. And so this generates or auto generates the 2-byte route target format based on RFC 4364, and you can see the representation there as the ASN 65100:10. And then when you don't have the auto mode legacy configured, which is the default, then it generates the 4-byte format. As you can see here, this still has the same ASN number, but there's a 4-byte representation for the suffix. And then in figure 3, we're kind of just showing you the pre-10.15 behavior. Depending on the route targets that had been created, you'd need to have a manual import for the ASN based on either the 2-byte or the 4-byte format, and this is just showing an example of that. So either the 65200:10 or the 4-byte format that you see here. And so these are still required if you don't have the replace RT ASN configured within the BGP context, as you can see here. So our neighbor 6.6.6.6 is the border VTEP. And so without replace RT ASN, the original route target is just still going to come in. So it would be coming in as 65200 as the ASN, when we can see that the ASN for this router is 65100. So that won't get rewritten unless you issue the replace RT ASN command. So just keep in mind that the manual route targets are still needed if you don't use the replace RT ASN command. So changes to both of these feature configurations. So the replace RT ASN configurations do require that the BGP sessions get restarted using the clear BGP star command. However, changes made to the route target auto mode command don't require any session restarts. However, the mode needs to be consistently configured across the EVPN fabrics. So for best practices, we want to configure the route target auto mode legacy on each of the devices in the fabric. And we want to use the replace RT ASN features at each of the borders and the leaf nodes so that the route targets can be automatically replaced to match the local ASN. So again, in this case, packets coming from VM2 to VM1 would have the ASN rewritten to match 65100, even though they originated from ASN 65200. And by configuring these two features together, the routes are then programmed successfully on each leaf VTEP by nature of the route targets getting rewritten. And as mentioned here, you want to maintain consistency with regards to the auto mode selection across the entire fabric. Otherwise, you'll run into issues where the VXLAN tunnels won't be operational. And so for troubleshooting, there are two primary commands, which are the show EVPN EVI and the show BGP L2 VPN EVPN external community commands. And so these are used to see which route targets are auto-generated and in what format. And then also to track down any rewriting of the ASN numbers to track down the route targets for any specific MAC entries. And just the extra note here, you need to use the external community command because otherwise the route targets themselves won't be shown in just the show BGP L2 VPN EVPN command. So this is useful again to track down the route targets. And we've already mentioned this from a troubleshooting perspective. And we've already made mention of these two issues here. You do need to clear the BGP sessions when you're using the replace RTASN feature. And you don't need to do that when you're changing from the auto mode legacy command. And when these things aren't correct, as you can see, the route target imports won't be correct. Could be because of the wrong auto generation mode, and the tunnels won't get established and the MAC addresses won't be added to the MAC table. So just make sure you check these things and use these commands if you're running into any trouble. Okay, so let's take a look at these two features with a live demonstration. And as we've already covered in some of the prior slides, so this is a topology we'll be using for the demonstration. So we've got 4 routers here with 2 different fabrics. So you see the fabrics are illustrated here with ASN 65100 on the left and 65200 on the right. So it's iBGP, as you can tell, between these 2 routers, and then inter-fabric, we've got eBGP between fabric 65100 and 65200 with the 2 borders that you see there. And then we've kept it simple, so we're just using a single VLAN, so VLAN 10 here. We've got IP 10.1110, as you can see here, with a MAC address 00AA for VM1, and then on the other side for VM2, we've got MAC 00BB with IP address 10.1111, also in VLAN 10. And so we'll take a look at the communication here and what it looks like with the replace RTASN feature and the auto mode legacy features configured together. Okay, so let's walk you through the demo. So I've got the topology diagram just posted here down on the bottom just for reference. So, and then for orientation, we've got a border gateway 1, which is this router here up in the upper left, border gateway 2 in the upper right, and then leaf 1 on the left-hand side here, and leaf 2 in the middle here on the right-hand side, and then VM1 and VM2 here at the bottom of the screen. And so you'd see we've got configurations in place. And so in this demo, we can see that VM1 is able to communicate with VM2 and vice versa. So we'll show you first the pre-10.15 behavior where we've got the manual route target imports, and that's how things are working right now. So let's just kind of advance through this a little bit. Just showing you that we've got BGP is established, with the border gateways and the leaf nodes in each case. So just showing you that that's all up and running. And here's where we're taking a look at the EVPN configuration on each of the routers. So as mentioned, you can see we've got manual route target assignments here, across each of the routers in each of the fabrics, and this is how they're communicating now. It's so the routes are created here on the right-hand side for VM2, and they're going to be matching ASN number 65200. So that's required to be imported here on each side, in addition to the local ASN, which is 65100. So configured identically across each of the devices in the fabric. Okay, and so this is just where we're dumping the show EVPN EVI command to illustrate the route target imports and exports that have been triggered by this manual route target imports, and so they look correct across each of the routers. And now we're looking at the BGP configuration just to illustrate that we don't have any of the replace RTASN features enabled in any of the routers to start with. And now just dumping the MAC table, so you can see that we've got the MAC entries for each router that's learned through the fabric to the corresponding next hop. And we're also just showing you that we do have the tunnels established for each of the leaf nodes corresponding to the border gateways in each fabric. And now we're just showing the MAC table entries by issuing the show BGP L2 VPN EVPN external community commands. And so when we look at the entries, we can see that the ASN has not been rewritten. So for on leaf 1, the ASN is matching on 65100. We haven't rewritten that, and there was no need to do that at this point because we're just doing manual route target imports. And the same thing is true on the other side as well for these entries right here that we see learned. And also showing that the border gateways themselves also do not have any ASNs getting rewritten. The MAC entries match the actual originating ASN. Okay, and so now what we're going to do is go in and we're going to start making some changes to remove the manual route target imports and start using the auto-generated formats. So we've switched to route target auto mode legacy. So that's a new feature introduced with 10.15. And so then we're going to go ahead and we'll dump the EVI output that would show the, well, we still have the manual route target imports, so we'll remove those, but we should see this basically the same configuration after removing the manual route target imports. And we'll just move on through this, and we'll go ahead and remove each of the entries. And after removing each of the entries, you can see we still have, or we have the auto-generated format here. So the route target import and export of 65100:10 and 65200:10. But you will see as well, so we don't have any imports for the other fabric on either side. So you can see that we stopped communication between VM1 and VM2. And here's where we're going to go in and enter the replace RTASN features on each of the border gateways. And as we mentioned in the presentation, so clear BGP is required to restart each of the sessions. And you can see almost immediately we've got the communication reestablished between VM1 and VM2. And the reason being is that we've rewritten the ASN from 65.200 to 65.100 and vice versa. And we'll take a look at that by viewing the show BGP L2 VPN command. And now you can see for each of the borders, we can see that the ASN has been replaced to match the ASN of the router itself. So in this case, we can see all of the entries coming in from these next hops, even in the other fabrics, are now all showing the local ASN, so 65.100:10. And then in fabric 2, same thing is true where we see 65.200:10. And this is just an illustration that the replace RTASN feature is local to the router itself. So it doesn't manipulate the route target as it's exported out to the environment, to the VTEPs. So we need to actually issue the replace RTASN on these leaf nodes as well, so that we can remove the manual route target assignments that we have created. So issuing the same commands that we issued on the borders. So we've added the auto mode legacy commands. No changes to the EVI table currently. So no changes after issuing the auto mode legacy commands. And so now we're removing the manual route target assignments. And you can see right away we've disrupted things from the communication between VM1 and VM2. So this is where we're going to go in now and change the configuration to have the replace RTASN feature added. And you can see after adding the replace RTASN, we now started communication between VM1 and VM2 back up again. And that's reflected in the show BGP L2 VPN external community output, as you can see here. So now it's got the same ASN matching the border on each side. So 65.100:10 and 65.200:10. And just showing the configuration for EVPN now, we've replaced all the manual route target imports and exports and replaced them with auto-generated formats. And so you can see that we are able to reduce the configuration that's required by doing this. Imagine not just VLAN 10, but say you had 100 VLANs and you had to have all of those manual route target imports. This improves that experience for configuration for usability and simplicity. In here, what we're going to do is just change so you can see what the other format looks like. So we're going to remove the auto mode legacy command here, which will result in the default of the 4-byte format that we mentioned earlier. And you can see the dump, the show EVPN EVI, so you can see that we've got the 4-byte suffix now configured, or auto-generated, I should say. And as I mentioned previously, you can see we've disrupted the communication because you want to maintain consistency across all the devices in the fabric. So that's why we've disrupted communication here. And as soon as we configured, or as soon as we remove the route target auto mode legacy commands on each of the routers, now we have communication back again. So this is just highlighting that replace RTASN also does work with the 4-byte format as well as the 2-byte format. And just dumping the show BGP L2 VPN command again with external community, you can see that we're represented the 4 byte format now, but it has replaced the ASN with the local ASN number, as you can see reflected here. And that is the end of the demonstration. So we'll get back to the presentation. Okay, in this section, we'll briefly cover some additional resources that can help you to understand the feature better. So the basis for these features that we've outlined in this presentation are covered basically with the two RFCs that you see there, RFC 4364 and 8365, and then the hyperlinks for each of these as well. They document the route target formats, as you remember the 2 byte and the 4 byte distinction that we covered earlier in the presentation. So I encourage you to take a look at these RFCs if you're looking for more information. And to help with spinning up any environments that demonstrate these features, I've also included the configurations from the demo environment. So each of the routers that you see here, I've provided the configurations on the following slides. So we'll just pause here for a moment. So this is Border Gateway 1. You can see the auto mode legacy commands and then the replace RTASN commands from the neighboring router here. And then continuing on, so this is the Leaf 1 configuration, as you can see here. So we've got consistency here with the auto mode legacy and the replace RTASN commands. And for Border Gateway 2, so same thing, auto mode legacy, replace RTASN. And finally, the Leaf 2 configuration with the same features configured, just with a single VLAN. And with that, we've reached the end of the session. Hopefully this has been valuable, and I encourage you to reach out to the Airheads community. You can scan the QR code and sign up for the community today. It's a great place for resources. All the material from a lot of these training sessions are posted there. So that should help with understanding more about AOS-CX and the features that we offer on the CX brand.